Hello everyone and welcome to STEM School. Now in today's video we'll be going over exam questions where we need to use the properties of angles to find a specific angle from a complex diagram. Now these are tough problem solving questions, so I'll explain everything you need to know on how to tackle these questions correctly. So before I begin, please do like the video and consider subscribing to the channel, that'll be fantastic. Alright, let's get started. So in the exam, you get given a diagram and you're asked to find an angle, alright? You don't get given, any lengths of the lines, so you don't actually have to use trigonometry for these types of questions. Instead, it's just purely testing you on your knowledge of the properties of angles. So what I'll do is, I'll show you the list of the different properties that you just need to memorise, and that will help you do these questions correctly. So some of these actually might be familiar to you already, but I'll explain them all in a nice list so you can have them all in one place, okay? So if you look at rule number 1, you'll have seen this rule already. So when you have a straight line and an angled line like this, so this angle plus this angle will add up to 180. So A plus B will add up to 180, okay? That's fairly straightforward, alright? Now let's move on to rule 2. So the rule 2 is about quadrilaterals, which are four-sided shapes. So the angles in a quadrilateral in a four-sided shape, they all add up to 360 degrees. So that makes sense, whenever you have like a square or a rectangle, each corner is a 90 degrees, it's a right angle. So 90 plus 90 plus 90 plus 90, well that obviously adds up to 360 degrees. So this rule is just extending that to, all other four-sided shapes like this. You got a diamond and you got, a parallelogram as well. Alright, so let's move on to rule 3. So we're moving on to triangles now. So this rule states that the three angles in a triangle, they add up to 180 degrees. A plus B plus C is equal to 180 degrees, okay? This is for this topic anyway, for the diagrams that you get given, this is a common rule that you need to use, okay? So be sure to remember this one. Now if we move on to rule 4, again it's to do with triangles, but this time we're looking at equilateral triangles. Now an equilateral triangle is a triangle that has same length of sides. So the three sides in a triangle is the same length as each other. So what that means is the angles at each corner of an equilateral triangle are equal to each other. So what you do is 180 divided by 3 will give us 60 degrees at each corner. Okay, so that's how you figure that out. Now if we move on to rule 5, this is quite common in the diagrams that you get, is where you have to deal with isosceles triangles. So an isosceles triangle is where two sides of the triangle are the same length. Okay, then the third length is something different, okay? So when you get an isosceles triangle, so these two, the angles at the bottom two corners, those are the exact same angle. Okay, so that's the rule for isosceles triangle. This is very common. Quite often the diagrams that you get given, they might be circles. So these two lines here that are the same length, they're often, radius lines. Okay, so we know if it's a radius line, they're going to be the exact same length. All right. Okay, so let's move on to rule 6 now. So this is a rule called the Z shape, okay? So when you spot this Z shape in a diagram, what we know is this angle here and this angle here, they're going to be the exact same as each other, okay? That's a good rule to remember. It does make life easier when you're analysing these diagrams, alright? Now if we move on to rule 7, what we have is the F shape. Now the F shape is something like this, okay? So we have these two lines have to be parallel to each other. Okay, same with the Z shape, the two horizontal lines have to be parallel. So for the F shape, what we're saying is this angle here and this angle here are the exact same because the lines are parallel. Okay, so that makes sense. Alright, so let's move on to rule 8. So this is to X shapes. So when we have an X shape, what we can say is this angle here and this angle here, they're going to be the same. Then this angle here and this angle here, they're going to be the same, alright? Now what you'll also notice is that, see these four angles, they add up to 360 degrees, okay? Add up to 360 degrees, okay? Now let's continue, we've got this rule here, rule 9, okay? So rule 9 is actually quite similar to rule 6 about the Z shape, because if I draw this shape here, we can do this. We go like that, and we can make a Z shape just like that. Okay, so what that is saying, so if this angle is A, then this angle here will also be A. Okay, so that's how that works. And then if that angle is B, then this angle will also be B. Okay, then obviously these two angles, A plus B, they'll add up to 180 because it's a straight line. Same with the bottom there. Okay, so anyway, for rule 9, what it's saying is that A plus B will add up to 180 degrees, okay? Now, this rule isn't that important to remember. It's not the end of the world if you forget it. You know, you don't often actually have to use this rule for these types of questions, because there are other ways to, you know, find the angles in the diagram, okay? Now, if we go to rule 10, this is a common rule to remember, okay? So often you get asked some sort of circular diagram and you might get a tangent, okay? So when a tangent will hit the circle at a point on the circumference, so if you draw a perpendicular line where the tangent hits the circle to the centre of the circle, that's going to be a perpendicular line, okay? So the tangent hits the circle at a perpendicular angle, which is 90 degrees, okay? And that's a good starting point where you're tackling these types of questions, okay? So this is a crucial rule to remember. Now, rule 11 is a very useful rule to remember because it does make life easier, alright? So what this rule is about semicircles. So whenever you have a semicircle, so whenever you have a triangle in a semicircle just like this, well, that triangle is always going to be right angled, okay? So we have a semicircle, so it's half of a circle, and see the hypotenuse of the triangle, that's going to be the diameter, okay? So as long as it's, you know, that kind of scenario, that's when you know it's a right angle triangle. Okay, so that's going to be the hypotenuse of the triangle, right? Okay, so these 11 rules are the properties of angles that I do recommend you learn. And if you do remember these, it will make life easier for tackling the exam questions that we're going to have a go at next, alright? Alright, so before we have a go at the first exam question then, I've written some tips here that are good to memorise for approaching these types of questions. So, questions on angles, the diagrams tend to include, you know, a circle, a triangle, and even tangents, right? So when there's a tangent involved in the diagram, that is a good place to start working out angles from, okay? Now, the next tip that when you have, you know, circles, right, you obviously have the radius. A good thing to do at the start is mark the radius lines as equal length, right? Because that'll make it easier for you to spot, you know, triangles. And what you'll find is that you can, you know, spot isosceles triangles, and then you can refer back to, you know, the angle property of isosceles triangles to work out angles from there, alright? So what we'll do is we'll have a look at this question. So here we have this first exam question. It's a circular diagram as expected. So we are told that lines AB and line CB are tangents to the circle, okay? So the tangents hit the circle at a point on the circumference. Then line AC and line AED are parallel to each other, and angle AOD is 143 degrees. That's this angle here, 143 degrees. And what we have to do is calculate the size of angle ABC, this shaded angle here. Okay, so when I look at this diagram, the first thing that I want to focus on is the tangents, right? There's actually two tangents, okay? So when we have a tangent, we know that the tangent hits the circle at a 90 degree angle. So what I'll do is immediately plot that on the diagram there. So this angle here, BAO, is a 90 degree angle, okay? Then the next step that I tend to do is when you tend to have circles, I'll mark out the radius lines so I can show that they're equal length. So this line here from O to E, that's the radius. Then the line from O to A, that's also the radius, and then the line from O to D, that's also a radius line, okay? Now, the next step is to actually appreciate is that this line from A to B and the line from B to C are also equal length, right? Because they're two tangents. So again, I can put this wee mark here just to show that they're equal lengths, right? So what we can see is this triangle ABC. What we actually have is an isosceles triangle because we have two sides that are the same length. So what that means is this angle here and this angle here are going to be the same, okay? So we figured out that much so far. Okay, so let's keep going. Let's try work out some angles. So if I look at this bit here, 143 degrees, we have a straight line. So we know this angle plus this angle here is going to add up to 180, okay? So what we have here is 180 degrees, take away 143 degrees, and that will give us 37 degrees there, okay? So we know it's 37 degrees over here, okay? So we found out one angle. Now let's keep going, let's find some more angles. Well, if you remember at the start where I talked about Z shapes, okay, what I'll do is I'll draw this a bit more clearly. What we have here is the Z shape here. Goes down the way, goes down to A, and then up the way. Okay, we can see a Z shape. That's what you tend to do when you look at diagrams like this. Try to see any of these common shapes, right? So I can see a Z shape. So if it's 37 degrees here, well, I know it's going to be 37 degrees over here as well, okay, using the Z shape rule, okay? Now, because I know this angle is 37 degrees, and I know that angle, OAB is a perpendicular, because it's a tangent, then I can work out this angle here, okay? So let's do that. So it'll be 90 degrees take away 37 degrees to work out this angle here. So what that'll give us is 53 degrees over here. So we know it's 53 degrees. Okay. Now, as we said before, we have an isosceles triangle ABC. Now, because it's an isosceles triangle, this angle here will also be 53 degrees. Okay. Just remembering the rule of isosceles triangles. So now we can easily calculate this shaded angle here, because the angles in the triangle add up to 180, okay? So we can do 180, take away 53 degrees, take away 53 degrees, and what that leaves us with is 74 degrees as the final answer for angle ABC, okay? So we can just, when you finalize your answer, just say, that's angle ABC, just to make it clear to the examiner what angle is what, okay? So angle ABC is calculated as 74 degrees, okay? So that is the general process. When you look at diagrams like this, try to spot shapes, okay, like the Z shapes, and try to spot, radius, try to spot tangents, okay? That's a good starting point for approaching these types of questions. Alright, so we'll have a go at this second exam question then. Now, if we look at this diagram, what we have is a circle, and we also have a tangent, right? It's very typical of this topic, right? So in the question, we're told explicitly that line A, B, and E is a tangent to the circle with centre O. And we're also told an angle DBE, which is this angle here, is 58 degrees. And now we're told to calculate the size of angle CAB, which is this shaded angle here, okay? Now, because it is problem solving, one thing I would do first of all is deal with the tangent, okay? Now, we know that the tangent hits the circle at a perpendicular, it's at 90 degrees, okay? So what I can do is ABE is perpendicular to line BO, okay? So I could put a right angle symbol here and then a right angle symbol on the other side as well, okay? Now, the next thing that I would do, following the rules that I mentioned at the top, is mark the radius lines, just to show that they're equal length, and then hopefully we can maybe see some isosceles triangles, something like that. So we know that line OC is a radius, line OB is a radius, and line OD is also a radius, okay? Now, already I can see an isosceles triangle OCB, okay? Now, I also mentioned for rule 11, for the properties of angles, right? When you have a semicircle and you have a triangle in the semicircle, well, that triangle is a right angle triangle, okay? As long as the hypotenuse of the triangle is at the diameter line, so it's at the center of the circle, just like that. So what I can do, we have a right angle triangle from B to C up to D. This is a right angle triangle. So again, I can mark that on the diagram. Now, this is actually a hard thing to notice, it's easy to miss, but what I will say is, it's not the end of the world if you do forget that rule, because there are other ways to find all the other angles in this diagram, okay? So, but again, if you do remember that rule, it does make life easier anyway. Okay, so let's find some angles then. So let's deal with the tangent. So we have 58 degrees and we have this right angle here, 90 degrees. So we can find this angle here. Okay, so let's do that. So it will just be 90 degrees, take away 58 degrees, and that will give us 32 degrees. Okay, so what we can do is put 32 degrees over here. Okay, now what I can then do is from that I can find this angle here because I know it's a right angle triangle BCD. Okay, so what I can do is 90 degrees take away 32 degrees and that will give me 58 degrees. Okay, so we can mark that down as being 58 degrees on this side here. Okay, so you can double check 58 plus 32 is indeed 90 degrees, which makes sense because you have a right angle triangle. Okay, now let's keep going. We're working towards point angle ABC, angle CAB, sorry. Okay, so if you look at this diagram, we have OCB. This is an isosceles triangle. Okay, so this is a radius line, OC, and then OB is also a radius line. So they're the same length. We have an isosceles triangle. Now, if you follow this rule, then this angle here will also be 58 degrees. Okay. Now we can use the straight line 180 degree rule to figure out this angle here. So let's do that. So it'll be 180 degrees, take away 58 degrees, and that will give us 122 degrees over here. So let's put that down, 122 degrees. Okay, so we have a straight line, so 58 plus 122 equals 180 degrees as normal. Now let's turn our attention to this angle here. Okay, now we're going to use the perpendicular aspect of it to find this missing angle here. So what we have is that 180 degrees, well, we can take away 58 degrees, we can take away 32 degrees, taking away 58 degrees, take away 32 degrees, take away 58 degrees again, and that should give us the angle here. Okay, so what that leaves us with is 32 degrees as well. Okay, so we can put that down, 32 degrees over here. There we go. Now what we have here is another triangle ABC, and we have one missing angle here. So we can use the fact that all angles in a triangle add up to 180. Okay, so it'll be 180, take away 122 degrees, take away 32 degrees. So that'll give us the missing angle of 26 degrees as the final answer. And there we go. So yeah, that was a little bit tricky, but if you remember that crucial rule where you have a semicircle, have a right angle triangle, and if you have a triangle in a semicircle, then that triangle is a right angle triangle. Okay, it makes your life so much easier if you remember that. Okay, but hopefully this explanation has helped you understand how to do this question. And finally, we have this exam question here. So let's have a look at this. What we have is a circle, and I can see some triangles, and I can also see a tangent down there, right? Very typical for this topic. So we're told specifically that line AC is a tangent to the circle. It hits the circle at point B, and the circle has center O, right? Now we're told the line D to E is the diameter of the circle, and point F here is just a point on the circumference. Okay. Now we're told two angles. We're told that this angle is 77 degrees, and we're told that this angle here is 64 degrees. And what we have to do is calculate the size of angle BDF. All right. So what's BDF? So we have BDF. Okay, so we need to find this angle here. There we go. Alright, so let's have a go at this question. So typically you'll start off with the tangent, okay, because we know that the tangent hits the circle at a 90-degree angle. So what we can say is that here we have a right angle, and here we also have a right angle, okay, on the other side of the line. Alright, now the next step, what I would do is mark the radius lines just to show that they're the same length. So we have line OB, and then we have line OE, and then we have line OD. These are all radius lines, okay? Now, hopefully by doing that, I can spot, some isosceles triangles. So I can already spot two isosceles triangles. What I have is a triangle OBE. Okay, that's an isosceles triangle. and I also have like triangle OBD as well, OBD. So I have two isosceles triangles, so hopefully that will help us at some point. Now, if I also look at this diagram, right, what if you remember to rule 11 from the start of the video, whenever you have a triangle in a semicircle, that triangle is going to be a right angle triangle, okay? So as long as the hypotenuse of the triangle is the diameter of the circle, just like this, okay? So what we can say is that we have a triangle DEF. Oh, it's a right angle triangle because it's a semicircle and you have a triangle in it. But we also have the other side of the circle, we have DBE. That's another right angle triangle, alright? Now, like I said, if you do forget that rule, because it is easy to forget it, there are other ways to find angles from this diagram, okay? So it's not the end of this world, right? Now, we've marked everything that we know. Now, this specifically finds some angles, okay? So it makes sense to start off with a tangent. So let's look at this angle here, next to the 77 degrees. Now, because we have a tangent and we have a perpendicular line, we know it's 90 degrees. We can say it will be 90 degrees, take away 70 degrees, and that will give us a small angle of 13 degrees in that wee slot there. So it's going to be 13 degrees, just like that. Okay, now like I said, hopefully you spotted that it's an isosceles triangle OB to D, because we have the radius line here, OD, and the radius line O to B. So since it's an isosceles triangle, this corner will be 13 degrees, but also this top corner here will also be 13 degrees, okay? So we found a crucial angle there as part of angle BDF, okay? Now let's continue. So what I want to do is find this angle here, okay? Now, what we can do is focus on the right angle triangle, DBE. Now, because we know a fraction of the angle, of this angle, because of the right angle, it's 13 degrees plus x is equal to the 90 degrees here. So what we can do is 90 degrees, take away 13 degrees, and that will give us 77 degrees. Okay, so hopefully you can spot that. So it'll be 70 degrees from this line down to this line. Okay, so 77 plus 13 is equal to 90, which gives us this right angle here. Okay, now again, what we have is an isosceles triangle. We have triangle OBE. We have the radius line OB and the radius line OE. So if this corner of the triangle is 77 degrees, then this corner of the triangle is also 77 degrees. There we go. Okay, so what we can then do is move on to this right angle triangle, DEF. Okay, we know 3 angles add up to 180. We know 2 of the angles. So what we can do is 180, take away the 90 degrees here, and then take away the 64 degrees at the other corner. So what that gives us is 26 degrees. And there we go. So if this corner is 26 degrees, then we can just add both of these angles together to find angle BDF. Okay, and that's the final answer. Angle BDF is simply going to be 13 degrees from here, then plus the 26 degrees next to it. So what that gives us is the final angle of 39 degrees. Alright, so there we have it. That's the final answer. Angle BDF, 39 degrees. So as you saw, these questions are very much just problem solving based, but if you memorize the rules from the beginning of the video, like the tangent rule, isosceles triangle rule and the semicircle rule, and you follow my process of starting these questions, then you'll be absolutely fine for the exam. So you just need to get as much practice as you can. Now, if this video has helped you, please do remember to like the video and consider subscribing to the channel. And I'll see you in my next video where I'll explain the change the subject question from the algebra topic. Alright, so I'll see you guys then.